All right, today we are going to be talking about absolute value equations. So you learned about absolute values in your previous math classes, and so you'll have some review questions in your ALEX work that will remind you just how to deal with an absolute value. But an absolute value equation is an equation that contains an absolute value expression and represents distance from zero on a number line. So when you first learned about absolute values, that's how they would explain it to you. And so they would say, okay, the absolute value of 9 means how far is 9 from 0 on the number line. And so you would say, well, it's 9 units. And so the absolute value of 9 is 9. But you also have, let's say, the absolute value of -7. That's asking how many units is -7 from 0 on the number line. And if you don't know, you could look at this number line. Here's -7. If I count to 0, 1, 2, 3, 4, 5, 6, 7. So the absolute value of -7 is 7. And so I want to make sure that you have the right notation. Absolute value is never going to be negative. Now, I don't say always positive because it could be 0, and 0 is neither positive nor negative. But absolute value, because it represents a distance, and distance can't be negative, that's why we say absolute value is never negative. So what I want you to do here is look at this example that I've got kind of names of different fictitious students here. And it says, in the picture above, name the student or students who are 5 units from 0 on the number line. So here's 0 right here. I want you to count and see which of these students, and if you just want to count how many units each student is and write it down, we already know Derek is 7 units away from 0 because we counted from -7 to 0 before. So go ahead and pause the recording and write down the students who are 5 units from 0 on that number line. All right, hopefully when you went through, you looked at Kia, and here she is at -5. And if you count, that's 1, 2, 3, 4, 5 units from 0. So Kia would definitely be a winner there. When I look at Mara, here's Mara, 1, 2, 3 units from 0. Israel is 1, 2 units from 0. Laura is no units from 0 because she's at 0. Tanya is 1, 2 units away from 0. Antoine is 1, 2, 3 units from 0. Nick is 1, 2, 3, 4, 5 units from 0. So that means Kia and Nick are both 5 units. Sam, 1, 2, 3, 4, 5, 6 units away from 0. So both Kia and Nick are 5 units from 0 on the number line. And we can represent 5 units from 0 as an absolute value equation. Absolute value of x equals 5. So if this means the same thing as 5 units from 0, then go ahead and think about and write down right here how many solutions this equation has to have if this equation is the same as asking how many are 5 units from 0. So hopefully you came up with 2. This equation has two solutions because there could be two students that are 5 units away. One 5 units in the negative direction, one 5 units in the positive direction. So this is always true. If your absolute value has any solutions, it's either going to have none, 1 if it's actually 0, and most often it's going to have 2. So what you are going to do is when you are solving an absolute value equation, these are the steps we're going to use. And we're going to set up 2 cases every time. Now, sometimes when we set up the 2 cases and then solve, when we go to check, we find out that our solutions don't work. And in that case, then we might say that there's, no solution or only one solution. But we're always going to assume that there are 2 when we set them up, because most of the time there are 2. So when we look at example 1a, step 1 says to isolate the absolute value expression. That just means get the bars alone. So these are absolute value bars, and they are alone because I only have what's inside the bars, and that's it. So it's already isolated in this case, which means I set up the 2 cases. So case 1, I take the expression that was in the bars, which is w minus 7, and I set it equal to whatever the answer was. So in this case, 9. So that's case 1. Notice that you don't actually write the bars this time. So I'm going to write that over here. Don't write the bars. That's the whole point of setting up the 2 cases, is that we don't need the bars anymore. So this is case 1. Case 2, we take the expression in the bars again, w minus 7, and we set it equal to the opposite of the answer. So the opposite of 9 is negative 9. Step 3, we're going to solve each case, and these are very simple equations to solve. Add 7 to both sides. 9 plus 7 is 16. Over here, when I add 7 to both sides, negative 9 plus 7 is negative 2. So I have 2 solutions. Now I need to check them. 16 minus 7 is 9. Is the absolute value of 9 equal to 9? Well, I sure hope so, because I told you it was right up here. So I checked this one. That one works. So now check this one. Negative 2 minus 7 is negative 9. The absolute value of negative 9 is also 9. So this checks, which means there are indeed 2 solutions. So I can write an and between them. All right, now I'm going to move on to B. Step 1, isolate the absolute value expression. That's the bars. So I need to get this all by itself. So that means I need to get rid of this added 5 that's outside the bars by subtracting. So that gives me 4 times the absolute value of 2y minus 7 equals 9 minus 5, which is 4. My bars are still not alone. I've got this 4 in front, which is multiplied because there's no operation written. And remember that when there's no operation written, it's understood to be multiplication. So we're going to undo that with division. So that'll cancel these out, and that'll get my bars alone on the left side. On the right side, 4 divided by 4 is 1. Okay, bars are alone. Check for step 1. Now I set up my 2 cases. So case 1, I take the expression that was in the bars, which is 2y minus 7, and I set it equal to the answer, which is 1. Case 2, take what was in the bars, 2y minus 7, down here, set it equal to the opposite of the answer. So equals negative 1. And now I'm going to solve. So need to add 7. Gives me 2y equals 1 plus 7 equals 8. Then I need to divide by 2, and I get y equals 4. Now solve case 2. Add 7 to both sides. That gives me 2y equals 6 this time, because it's negative 1 plus 7. Divide both sides by 2. I get y equals 3. So now I need to check it. So make sure you use order of operations when you check. So when I go to check, here I have 4 times the absolute value of 2 times 4 minus 7 plus 5, and I want that to equal 9. So 2 times 4 is 8. 8 minus 7 is 1. The absolute value of 1 is 1. 4 times 1 is 4. 4 plus 5 is indeed 9. So the y equals 4 checks out. Now I'm going to check the y equals 3. So I have 4 times the absolute value of 2 times 3 minus 7 plus 5 equals 9. Again, absolute values are like parentheses, so I need to do what's in those first. 2 times 3 is 6. 6 minus 7 is negative 1. The absolute value of negative 1 is 1. 4 times 1 is 4, plus 5 is indeed 9. So in this case, again, both of them work, and those are my 2 solutions. All right, next. Here, I need to isolate my absolute value expression, so meaning get the bars alone. So that means I need to subtract 6 on both sides. So absolute value of 5x plus 9 is equal to 1 minus 6 is negative 5. So bars are alone, so I set up my 2 cases. Case 1, set what was in the bars equal to the answer. Case 2, set what was in the bars, which is 5x plus 9, equal to the opposite of the answer. The opposite of negative 5 is 5. Now I'm going to solve both cases. So in this case, subtract 9, 5x equals, that'd be negative 14. Divide by 5, x equals negative 14 fifths. Solve case 2. Subtract 9 on both sides first. 5x equals negative 4 is what I get when I do 5 minus 9. Divide by 5. X equals negative 4 fifths. So now I need to check it. So 5 times negative 14 fifths. The 2 5s are going to cancel each other out. So that just gives me negative 14. Negative 14 plus 9 is negative 5. The absolute value of negative 5 is 5. 5 plus 6 is not 1. 5 plus 6 is 11. So this does not work. So now I try to check this guy. So plug it in. 5 times negative 4 fifths. The 5s just cancel, so that gives me negative 4. Negative 4 plus 9 is 5. Absolute value of 5, still 5. And 5 plus 6 is 11, not 1. So neither of these work. This is no solution. Now, let me teach you a trick for spotting no solutions. It's a no solution if you have an absolute value equal to a negative. Because absolute value is a distance. Distance can't be negative. So if you've isolated and it's equal to a negative, one trick, if you can remember it, is that that's always no solution. So you can go through the cases and the checking. If you think you're not going to remember that rule, obviously we still got that same answer, but absolute value is a distance, and distance cannot be a negative. So that's a little trick for you. All right, last one. isolate the bars. So that is already done. Here are my bars. It's already by itself. So set up my two cases. Case 1, expression from the bars equal to the answer. Case 2, expression from the bars equal to the opposite. Now be careful here because it's not just a number. The opposite of A means that you multiply the answer by -1. If I multiply this whole guy by -1, it has to be distributed. So that would equal -3x plus 2. So just be careful with those. All right, now I want to solve. So get all my x's to one side. So subtract 3x on both sides. X minus 3x is -2x plus 6 equals 2. Now, since my x's are on the left, I'm going to get my constants to the right by subtracting 6 on both sides. 2 minus 6 is -4, so divide by -2, and I get x equals 2, because negative divided by a negative is a positive. So now I need to do the same over here. So add 3x to both sides. In this case, those go away. 3x plus x is 4x plus 6 equals 2. Subtract 6 on both sides to get all my constants to the right. 2 minus 6 is -4. Divide both sides by -4. And I get x equals -1. So in this case, I need to check. So 2 plus 6 is 8. The absolute value of 8 is 8. 3 times 2 is 6. 6 minus 2 is 4. 8 not equal to 4. So this guy does not work. So then, when I go over to case 2 to check the -1, -1 plus 6 is 5. The absolute value of 5 is 5. And on the right side, I get 3 times -1 is -3. Minus 2 is -5. 5 does not equal -5. So this one is also a no solution. All right, so we've illustrated some absolute values for you here. So make sure that you understand what we did in setting up the two cases and reach out if you have any questions.